I'm going to be going over a little bit on page 6 and 7 of your packet just to help you get started. Remember, so if you start at lesson 1 and you number the pages starting with 1, this will be page 6. And so I'll just do a few questions on page 6 and 7 to get you going here. So let's see. Let's start with this first question. Similar to how we did the warm-up, I would recommend filling in on the diagram all the central angles and arc measures if you want. So we have a 21-degree central angle. This would also be 21 degrees because they're vertical to each other. And then if we take 180 and we subtract 21, that would give us 159. So first step, I would recommend just kind of filling in the central angles to a diagram. Now all we're looking for is kind of going into our diagram and filling this in. So from J to K, well, if our central angle is 21, our arc angle measure will also be 21. J and M, so J and M, that would be this angle measure here, 159. KL, also 159. And then we see a 3-letter, so typically that'll let me know that it's more than 180 degrees, a major arc. So from J to K to M, J, K to M, and you want to go in that direction, starting with J, then go to K, then go to M. So you're going to want to add 121 plus 159, or just 180, plus 21, so that'll be 201. And then let's do a different color for MKL. So starting at M, going to K, and then all the way around to L. Is that right? M. Oh, I can't backtrack to L or go around the circle more than once. So excuse me there. We're going to start from M, and then we're going to go to all the way to K and then to L. So here we go. So it is basically everything, the 360 total, and instead we're going to subtract this time. So let's subtract 21. That'll be 339. So if you're tracing an image and kind of doing similar to what I did, and you're going M to K, and then you're retracing it, or you're having to go M, K, and then backwards, then you're going to need to go in the opposite direction on the circle. Okay. Let's look at questions that have maybe some solving for X here. So what we notice is that this arc, so if you have something showing here, I would just do that expression for the letters that it's between. And then we have our 26. So these two together are going to add up to 180. So let's take 15x minus 26 plus 26, and let's set it equal to 180 because it's half of a circle. Okay. We can also do that for this diagram here. We have 15 degrees, but if I look at these 3 angles, or no, actually, let's see, 15. Actually, what we're going to want to do first is, excuse my diagram there, or my little arc. What I have is 103 degrees here. And then this is also going to be 103 degrees together. Because if you're noticing, this line is a diameter, this line is a diameter. So we have actually some vertical angles. So that would be this part here is vertical to this part here. And let me actually get my white out to take off this piece. All right, so actually what we're going to be doing is this angle, which is 103, is going to equal these 2 angles added together. So we can add these 2 together, set it equal to that 103. Let's get a few other things set up or kind of diagrammed. We have one here with a 90-degree angle. So remember, anytime you see this little symbol here, that's going to be 90 degrees. And it looks like this is going to be the full circle 360. So I would add everything that you have here. 8x, if it's helpful for you to line up all your expressions. 8x, this one, and then we have a 90. So I would add all of these together, add all of your x's, add all your numbers together, and then you can equal it to 360. Okay, so this page here, page 6, is just a review of the central angles for a circle. And then if you're looking at page 7, let's go here. You are naming parts to a circle. So I'd look back on your toolkit on page 18. And then you're finding area, finding circumference. Remember, when it has an equal sign, you can do the exact area. an exact circumference. If you want to give approximations after that, you can. Also for this question, keep in mind 25 is the diameter, so you will need to find the radius for that. So the radius is half the diameter, so radius is 12 and a half, 12.5. For this question, you're kind of doing similar what we did to the warm-up, and same with this one. Now, when you see question 13, this is kind of our mistake here. We realized that we are actually giving you a question that we haven't gone over. So when it says arc length, maybe let's just have you do angle measure for this one. So measure of ST of that angle. And let's have you do measure of RPT, so the angle measure. So we're not talking about length quite yet because we'll actually be working on that in lesson 3 with sectors, areas, and arc lengths. So please remember, come to office hours, see if you need help on any of these pages 1 through 7 so far.